So hi and hello. Welcome to our channel named Algo Exploration. My name is Samir. Now in today's lecture, we are going to learn that how to find the maximum subarray of length k. What the question is saying that we have to create the subarray of size 3. Okay, so what do you mean by subarray? It will be a part of array. Okay, so starting from 0, the length of the subarray should be 3. So this will be the first subarray, second subarray, third subarray, and fourth subarray. Okay, so after finding all the subarrays, we have to calculate its sum. So the sum of the first subarray will be 8, right? 1 plus 2, 2 plus 1 plus 5, that will be 8, right? So the second subarray will have the sum of 1 plus 5 plus 1, that will be 7. In this way, we have to find the sum of all the subarrays, but we have to return the maximum of all. Okay, so the sum of this subarray will be 8. The sum of second subarray will be 1 plus 5 plus 1, that will be 7. The sum of third subarray will be 5 plus 1 plus 3, that will be 9. And the sum of last subarray will be 1 plus 3 plus 1, that will be 5. So we can see that here 9 is leading, right? So we have to return 9 as our answer. So let's see that how we can solve this problem. But before that, let me tell you one thing, that we have started a series on DSA problem. If you know the fundamentals of DSA but getting stuck while solving the DSA problem, this series will be very helpful for you. If you are preparing for placement and interviews, you can visit to this playlist. The link is in the description box. Thank you. Now let's come to our problem. As always, we have to start with the brute force approach. So approach 1, that will be brute force. Now what we will be doing here, we will be calculating all the subarrays. Okay, and then in each subarray we will be calculating its sum. The starting point of first subarray will be 0. The start will be 0 and end, since the value of k is 3, so end will be index 2, right? The next subarray will be starting from 1 and the ending will be 3. 2, 4, 3, and then 5. We will not go for 4 and 6 because here the length of an array is 6. The index will be 5. Now in each subarray we will be calculating this sum. And how can we calculate? By iterating from 0 to 2. So iterate from 0 to 2, the sum will be 8. Iterate from 1 to 3, the sum will be 7. Iterate from 2 to 4, the sum will be 9. Iterate from 3 to 5, the sum will be 5. And at last return the maximum. So the code will look like this. Here initially my start will be 0 and my end will be k minus 1. You can see that the end is 2 here. So 3 minus 1, that will be 2. Now using the while loop, the condition will be we have to stop at last index, right? So we can see that the end is 5. So my end should be lesser than n. This will be the condition. Now after calculating every subarray, we have to iterate on each subarray, right? So we will be using for loop. So I will be starting from S and it will go till E, right? Now here we have to take the help of some variable because every time the sum is changing, right? So whenever my start and ends are changing, I'll initialize my sum to 0 every time. Now sum plus equals to a of I. Now using this for loop, we will be getting our first sum as 8. Now what we have to do, we have to take the help of another variable that will be max. So if max is lesser than sum, then we will be updating the max, right? This is very easy. Now after that we have to increment our start and end. So increment the start and increment the end. That's it. And at last return max. So this is the brute force approach. Let's try to find the time complexity. Here we can see that we are calculating every subarrays, right? Now in each subarray we are iterating for k number of times, right? Here initially my value of I will be s and it will go till e, and from s to e the length will be k, right? So the while loop will be running for n time, and this inner for loop will run for k time, right? So the time complexity will be order of n into k. But what if my value of k is n? At that time this will be order of n into n, that leads to n square, right? The space complexity will be order of 1 because we didn't take any extra space here. Now the time complexity is n square. Even if it is not n square, it is still n into k, right? Which is huge. So we have to optimize our solution. So let's come at approach 2. Again, if you didn't understand this approach well, I'll advise you to please dry run this code by yourself, because if you dry run it by yourself now, then you will get an idea that what is happening here. Okay, now before going to approach 2, let's see what is prefix sum and how to create a prefix sum array. Now here we have an array of 2, 5, 2, 1, 5, 1, 3, 1. Now the indexes are 0, 1, 2, 3, 4, and 5. Now if I want to calculate the sum of every element till 0, index 0, it will be simple, 2 only, sum. Now if I want to calculate the sum of every element from 0 to 1, 0 to 1, this will be 3. Similarly, if I want to calculate the sum of every index from 0 to 2, it will be 2 plus 1 plus 5, that will be 8. For 3, it will be 9. For 4, it will be 12. For 5, it will be 13, right? Now, what you can do, how you can find these values? First approach will be, let's say, if you want to find the sum till index 4, you can have a for loop starting from 0 to 4, right? For 5 also, what you can do, have a for loop starting from 0 to 5. This is the first approach. But the second approach might be, since you know that till this point, let's say I want to calculate of index 4, we know that till index 3 I have my sum as 9. I'll simply add 3 to my 9, so I will be getting 12 as my answer. Similarly, till this point I have my answer as 12, and I want to find the prefix sum or sum till index 5, so I will be adding 1 to this 12. I will be getting 13 as my answer, right? So the for loop will look like this. For I will be running from 1 I should be lesser than n I plus plus. I'll tell you in a minute that why I have started with 1, but see, and all this, let's say all this we are storing in an array, and the array name is prefix sum. So in short, I will be writing pf. Now if I want to calculate pf of, let's say, 3, so I will be considering this 8, which is pf of I minus 1, right? That is 2, and I will be adding 1 to it. So pf of I minus 1 plus a of I. Let's say the array name is a. So that's it. Now, what if I have started my for loop with 0? So if I start my for loop with 0, and if I execute this command, execute this line, so pf of 0 will be pf of 0 minus 1, that will be minus 1 plus a of 0. Now we don't have any value on pf of minus 1, right? So this will give us error. So due to that, I have started the I from 1. But what about this then? That how can we store which value can we store in pf of 0? It is simple, because we have only one element, so simply store a of 0 in p of 0. Pf of 0 is equals to a of 0, right? So in this way you can calculate the prefix sum array. Now try to focus here. The first subarray starting index will be 0 and the ending index will be 2. Second subarray starting index will be 1, end will be 3. 2, 4, 3, and then 5, right? Now for this subarray, the sum will be from 0 to index 2, right? From 0 to index 2, and we already know that 8 is nothing but the sum from 0 to 2, right, which is sorted. So 8 will be here. Now let's talk about the second subarray. This second subarray will be from 1 to 3, right? But what we have 9 here. And what does that mean? 9 means the sum from 0 to 3. So what if I subtract 2 from 9? Because we have these elements, but I don't want this, so I'll simply subtract 2 from 9. So I will be getting 7 as my answer. So 9 minus 2, that will be 7. Similarly, I want to calculate the sum of third subarray. The third subarrays start from 0 and end still 4. This one. And what do we have? We have 12. And what does that mean? It means the sum of every element starting from 0 to 4, right? And what do we don't want? We don't want this, because this subarray is this one. Now we have 12 and we don't want this, so I'll simply subtract 2 and 1 from 12, but we already have the sum of 2 and 1, which is situated here, right? So I'll simply subtract 3 from 12. So 12 minus 3, that will be 9, right? Now let's try to calculate the sum of last subarray. Will be from 3 to 5, 3 to 5, and we have 30. And what does that mean? The sum of every subarray, so the sum of every element starting from 0 to 3. And what do we don't want? We don't want these elements, and the sum of this element is stored here. So simply subtract 8 from 12 and you will get your answer. So 13 minus 8 is equals to 5. So using this, we are able to find the sum of every subarrays. How we can figure it out? What to put on code about these values? Because this is simple. These values are stored here, right? Now observe here, this 2 is actually present here, right, which is nothing but pf of s minus 1, right, because the value of s is 1 and s minus 1 will be 0. So this is what I'm trying to show. Similarly, 3, the value of s is 2, so 2 minus 1, that will be 1, so pf of 1 is 3. What about this? The value of s is 3 minus 1, that will be 2, and pf of 2 is nothing but 8. So I hope you understood this concept. So let's try to code this. Initially, s will be 0 and e will be k minus 1. Now, using the while loop in which e will be lesser than n, if my value of s is equals to 0, but here we can see that if my s is 0, I don't have to subtract anything, right? The answer is 8 only. So if my value of s is equals to 0, my sum will be pf of e, right? Pf of 2 is nothing but 8 here. So my sum is 8. But if this is not the case, then my sum will be pf of e minus pf of s minus 1, right? We have seen this here. Now, if my max is lesser than sum, then I'll update the max to sum. And after that, since we have to calculate the sum for each and every subarray, we have to increment s and e, right? So this will be the end of the while loop, and then return max, right? So this is the code. Let's try to find the time complexity. To find the prefix sum array, right, here we are taking order of n time, right? Here also in the while loop, in the worst case, we will be taking order of n time, right? It is not actually order of n. Here while loop is running only for the number of subarrays. Now try to comment it that how many subarrays will be present of size k if array size is n. Now, due to this, it will lead to order of n, right? Because both the loops are actually not dependent on each other. So order of n. And what about the space complexity? We can see that we have taken the help of extra space to find the prefix sum array. So this will be order of 1, sorry, order of n. But yes, there is some another approach that we can manipulate, or we can create this prefix sum in the original array only. But let's see the worst case scenario. What if the array is final, the original array is final, then we have to create another array to have our prefix sum. At that time, it will be order of n. Now there is one more approach. That approach is very famous, and this type of problems are actually solved using the technique. The technique is known as sliding window approach. Approach 3. Let's see that using sliding window technique, whether we will able to optimize our solution or not. The array will be 1, 5, 1, 1, 3, 1, and the indexes are 0, 1, 2, 3, 4, 5. Now this first subarray sum will be 8, right? From 0 to 2, the sum is 8. The next subarray, it will be from 0 to 3, right? But let's observe one thing. We have 8, that is nothing but the sum of these three values. So what if, since we are actually adding this one, so what if I do 8 plus 1, that will be 9, right? So you can say that since we are actually adding this one, then the subarray size will be 4, right? But what if I exclude this 2? That means minus 2. Then we will be getting answer as 7, right? This means that the 7 is nothing but the sum of 1, 5 and 1, because in the 8, first of all, we have added this value and then we have subtracted this 2, right? So in that way, we got 7. Let's go further now. The next subarray sum will be from 2 to 4. Let me write it here. The next subarray is from 2 to 4. And what do we have? We have 7. And what does that mean? The sum from 2 to 3. So if I add 7, if I add 3 in 7, then I will be including value 3 in this subarray, right? But we don't want this value because we want only this values. So I will be subtracting 1. So first add 3 and then subtract 1. So the answer will be 9, right? So actually we are sliding our window, and we are taking some certain actions. The actions are, if we are sliding the window is increasing at first, right? So due to that, we are adding this value, but we don't want the size of a window to 4. So we have to subtract this value, right? So we are subtracting it. Now let's slide our window again. So this window is from 3 to 5 and we have 9. So since we have slided our window and we have introduced this new value, so I will be adding 1, but we don't want this value now, right? So let's subtract this. So the value will be 5. I hope you understand this technique. Okay, so let's try to code this as well. First of all, we have to calculate the sum of first subarray, which will be simple. We will be using the for loop in which I will be running from 0 and it will be going till k. So the sum will be a of I. Right? I'll initialize the max as 0. Now we have calculated the sum of this subarray first. Now I have to slide my window. So let's create the s as 0 and I will be starting from k and it will be going till n. Now what we have done, since I want to slide my window to the right, I'm introducing this value to it. So I'll do sum plus a of I, right? We have added this value, but I want to subtract this also, right? So minus a of s, because initialize this s to 0. Now if my max is lesser than sum, then I'll update my max and then increment the s. And then at last return max. Here we have to initialize the max as sum. Now in this way you can solve this problem as well. So let's try to find the time complexity. this for loop is running for k time, and this for loop is running for n minus k time, right? And other than that, there is no other for loop, so no other loop, and we haven't taken any extra space. So k plus n minus k will give us n, that will be order of n, and the space complexity will be order of 1. Now you can see that we didn't take any extra space here, and still we solve this problem with the time complexity of order of 1, right? So this is the efficient approach. Now let's try to code this problem. So don't worry, I will be putting the problem link in the description box so that you can practice. So this is the same problem only. Now, as I said, that we have to first calculate the sum of first key elements. That will be the first subarray. For int I will be running from 0, and it will be going till k. Sum plus equals to array of I. Now you can see that they are actually expecting that the return type should be long, right? And we are storing the sum, we are storing the value sum in this variable sum, right? So we have to make the sum as well as max variable as long. Now after that, I have to update my max to sum, right? Now initialize the s to 0 using the another for loop in which my I will be running from k, and it will be going till array.length, right? Now sum will be sum plus, here we are sliding our window by 1, right? So array of I, and since we are sliding our window on the right side, we have to subtract some values, so it will be array of s. Now I have to check if my max is actually lesser than sum or not. If it is, then I'll update my max to sum, and at last increment the s. Let's return the max and let's try to compile and run. Okay, so let's do this. Let's try to compile this again. Okay, so you can see that this code is actually passing this single test case. Let's try to submit this. Okay, so you can see that this code has passed each and every test cases. So in this way you can solve this problem. This is a famous problem of called as maximum subarray sum of length k. Now thanks for watching this video till this point. So if you haven't subscribed to my channel, please subscribe it, because it takes some effort to create these long videos. If you're liking this series, do like this video, because it will encourage me to bring a lot of content like this. And don't forget to like, share and subscribe. Thank you.